Okay, welcome back to another video on the Maths channel. It's your teacher, Mr. Lim here. In this video, we're going to be looking at the chain rule. By the end of this lesson, you'll be able to explain what the chain rule is, identify when to use it, and use it to find the derivative of a composite function. So let's have a look at two recap questions. The first one says differentiate y is equal to 5x plus 2 all squared. So in order for us to do this, what we've learned previously is we should expand the brackets if it's easy enough. So here we've got a perfect square. So that's 25x squared plus 10 times 2 is 20x plus 2 squared is 4. And so now we can differentiate this with respect to x. That's going to equal to 50x plus 20. In question B, again another perfect square. So I'm going to expand this out because that's nice and easy to expand. 3 squared is 9. 3 times minus 4x is minus 12x. Times 2 is minus 24x. And negative 4x squared is positive 16x squared. Okay, so just remember when we've got a plus b squared, that's a squared plus 2ab plus b squared. And when we've got a minus b squared, that's a squared minus 2ab plus b squared. So now that we've expanded this, it's easy for us to differentiate. So when we differentiate this with respect to x, we will get negative 24 plus 32x. So, what is the chain rule? Suppose that y is a function of u, where u is a function of x. Then dy dx is equal to dy du times du dx. So this is the official definition of the chain rule, where we've got two derivatives multiplied by each other. The du's cancel here, leaving us with dy over dx, dy dx. So the two recap questions are examples of composite functions where instead of expanding and removing the brackets in order to find a derivative, we could use a chain rule. The chain rule makes life much easier when a composite function is much more complicated. So for example, if we have y is equal to 3x squared minus 4 to the power of 5, we could expand all of that, but that's going to take a very long time because that would be 3x squared minus 4 times 3x squared minus 4 times 3x squared minus 4, 5 times, right? It's just going to be it's going to take a lot of time to expand. So what we're going to do here with the chain rule is we're going to let u equal to 3x squared minus 4. So if we let u equal to that, technically we have y is equal to, that's u, to the power of 5. The reason why we want to do this is because if u is equal to 3x squared minus 4, then I can differentiate that with respect to x. That's just 6x. And I can differentiate this one with respect to u. That's 5u to the power of 4. So the chain rules tells us that dy dx is dy du times du dx because the u's will just cancel each other out. These will just cancel, giving us dy dx. So when we have a look at this, we can see, oh, dy du is 5u to the power of 4. You can see du dx is 6x. And so we can multiply these together, leaving us with 30x and then u to the power of 4. But we don't want to write it with a u. We want to always write it in terms of x, because we're differentiating with respect to x. So dy dx will be 30x times 3x squared minus 4 to the power of 4. Don't forget that power of 4. And that's much easier to differentiate. Okay, so this is called the chain rule. So when do we use the chain rule? Okay, we use it when we've got something in brackets to a power. So for question A, if I wanted to differentiate that, it's just 5. I don't need a chain rule, so no need. Same with B, it's just 7. C, that's just 24x squared, so don't need a chain rule. But this one here, yes, I need a chain rule because I've got something in brackets to a power. Now that power is 2, then You could use a chain rule, but it's probably easier to just expand a perfect square and then differentiate. But if it's not to, then just use a chain rule. So I would use it for D, I'd use it for E. For F, I would not. So I can see here that this is actually 41 to the power of 11 x to the power of 44. So if I wanted to differentiate this, then I don't need to use a chain rule. Question G, yep, I would definitely use a chain rule for that. That looks complicated. We've got something in brackets to a power. And for H, no, I wouldn't use a chain rule here because I could just simplify this as minus 3 x to the power of minus 12, and I can differentiate that easily. Okay? So, let's have a look at these ones. We want to differentiate this. We'll use the chain rule here. So if we let u equal to what's in the brackets, then technically y is equal to u squared. Okay, that's u to the power 2. So if I differentiate u with respect to x, I'll get 5. And if I differentiate y with respect to u, I'll get 2u. And since dy dx is dy du times du dx, dy du is 2u, and du dx is 5, so we can multiply them together to get 10u, but instead of writing u, I'm going to write 5x plus 2 in brackets. Okay, so you can see here that this works. However, I'm pretty sure this was the question that we answered at the very beginning where we expanded first and then differentiated. So I'm just going to scroll back up, 5x plus 2 squared. Yeah, that's up here. Can you see how little working out that is? So whenever it's a perfect square, just expand it and then differentiate. It will just make your life much easier. But when it's not 2, that's when I would use the chain rule. Okay? So, question B. We can see here we've got u is equal to 3 minus 4x. We can see therefore y is equal to u to the power negative 2. So if I differentiate u with respect to x, I'll get negative 4. And if I differentiate y with respect to u, bring down the power, reduce the power by 1, and that's what I get. So dy dx, we're just going to multiply, we're going to multiply dy du and du dx. So that's just minus 2u to the negative 3 times negative 4. Well, negative 2 times negative 4 is positive 8. I'm going to put this in the denominator. But instead of writing u cubed, I'm going to write 3 minus 4x in brackets cubed. Okay. Why don't you pause the video and have a go with C and D? Okay. So if we let u equal to what's in the brackets, y would equal to u to the power 6. Differentiate u with respect to x, we get 2x. Differentiate y with respect to u, we'll get 6u to the power 5. So dy dx, I'm going to multiply them. We'll get 2x times 6u to the power 5. That's equal to 12x, and u is x squared plus 1 to the power 5. Question D. I would rewrite this as 7 bracket 3x plus 4 to the power negative 5 first. And then I would say, we'll let u equal to what's in the brackets. So y is equal to 7u to the negative 5. Differentiate u with respect to x is 3. Differentiate y with respect to u, we'll get negative 35 u to the power negative 6. And so dy dx is dy du times du dx 3 times negative 35 u to the negative 6. 3 times negative 35, I'm pretty sure that's negative 105. I'm going to put this in a denominator with a positive power 6. But instead of writing u to the power 6, I'll be writing 3x plus 4 in brackets to the power 6. Okay, so I hope you got those ones correct. Now that's the official way to do it, but there is a shortcut method. Right, so let's have a look at this quicker method. What we're going to do is we're going to differentiate the outside, leaving the inside the same, and then multiply that answer with the derivative of what's inside the brackets. So the official formula for this is when y is equal to some function of x to the power of n, then the derivative is, we'll bring down the power, we'll write down f of x, we'll reduce the power by 1, just like normal, but then we need to times it by the derivative of what's in the brackets. Okay, so this is the technical formula that we have in our formula sheet. So let's have a look at our formula sheet. Okay, if I were to go here to our reference sheet here, that very top one in yellow, that is our chain rule. But I think the more official one is this one. So our formula sheet actually has both. Okay, dy dx is equal to dy du times du dx, but here we also have the shortcut method. I prefer you don't look at the reference sheet for this. I prefer you just know what to do. Bring down the power, write down what's in the brackets, reduce the power by 1, and then multiply by the derivative of what's in the brackets. So let me go through 2 examples, and then you can have a go with C and D. So in question A here, y dash, the first derivative, I'm going to bring the power down. I'm going to write down what's in the brackets. I'm going to reduce the power by 1. But I need to times by the derivative of what's in the brackets. So what do I get when I differentiate that? I get 2x. So my final answer is 12x bracket x squared plus 1 to the power of 5. Right, so this is a lot quicker than writing let u equal this, y is equal to u to the power of whatever, du, dx, dy, du, and then times them. Okay, this is much quicker. Right, so let's have a look at question B. The first derivative, we are going to bring down the power. 7 times negative 5 is negative 35. Write down what's in the brackets. Reduce the power by 1. Minus 5 minus 1 is negative 6, okay? So be careful with that. But we need to multiply by the derivative of what's in the brackets. What do I get when I differentiate that? I get 3. So that gives us our negative 105, 3x plus 4 to the negative 6. Now I'm happy for you to leave it like that. If you want to write it with a positive power only, then we can put that in the denominator. I'm absolutely fine with that. Okay, so why don't you pause the video, have a go with question C and D. Okay, question C. So y dash is equal to, bring down the power, write down what's in the brackets, reduce the power by 1, times by the derivative of what's in the brackets. When I differentiate that, I'll get negative 15x squared. So 7 times negative 15 is negative 105. Oh, whoops, I forgot my x squared. And then 3 minus 5x cubed to the power 6. Oops, no need for that. Question D. Y dash equals, bring down the power. Write what's in the brackets. Reduce the power by 1. times by the derivative of what's in the brackets. That's equal to 6x to the power 5 minus 4x. That's it. If you want to tidy up, you can. If you don't want to write that that dot that represents times, that's fine. Alright, and I think this is the last question for this video. Differentiate y is equal to 1 minus x to the power 4 to the power 4, and hence find the points on the curve where the tangent is horizontal. Now, where the tangent is horizontal means, if I were to draw a curve, if I were to draw the tangent here, at that point, it's not horizontal. Okay, if I were to draw it here, the tangent, not horizontal. The only times it's horizontal is at the turning points, where the gradient is 0. And remember, when we differentiate, we get the gradient function. So we want to make the gradient function equal to 0. So, y dash, bring down the power, write down what's in the brackets, reduce the power by 1, times by the derivative of what's in the brackets, negative 4x cubed. So that's going to give me a negative 16x cubed, bracket 1 minus x to the power 4 cubed. Okay? Now, hence find the points on the curve where the tangent is horizontal. So this is my gradient function. So I could say tangent horizontal when y dash is equal to 0. So 0 will equal to negative 16x cubed times 1 minus x to the power 4 cubed. So we can use our null factor law to determine that x has to equal to 0. That's for this one. Because 0, when x is 0, this will be 0 times something, which will be 0. Or, let's get rid of that one. This one here, 1 minus x to the power 4 will also need to equal to 0. Because if that equals to 0, then 0 times whatever this is will also equal to 0. So, I'll add x to the power 4 to both sides. I will take the fourth root. If I were to take the fourth root of 1, I will get plus minus 1. Okay, so we'll take the plus minus fourth root because that's an even power. So we will get 2 answers. So it seems like there will be 3 points where the curve, 3 points on the curve where the tangent is horizontal. So let's have a look. When x is equal to 0, y would equal to, so I'm just plotting 0 into here, okay, into here. Let's do this. 0 equals 1 minus answer to the power of 4 to the power, to the power of 4. That's equal to 1. When x is equal to 1, what's y equal to? 0. And when x is equal to negative 1, what's y equal to? 0 as well. So, therefore, tangent is horizontal. At 0, 1, 1, 0, and negative 1, 0. So let's just double check this on Desmos to make sure that we did this correctly. So we have y is equal to, I think it was 1 minus x to the power 4 to the power 4. Alright, there we go. So we can see here at minus 1, 0, at 0, 1, and at 1, 0, if we were to draw the tangents at each of these points, we would be drawing a horizontal line. Okay, the gradient will be 0. Right, and that's it for this video. I hope you found this video helpful. If you did, please give it a like and subscribe. And I'll see you in the next video. Thanks.